Hello, in this lecture we will find the area of a circle. In the drawing we have a circle and inside the circle we have a shape and angle ADC is a right angle, it equals to 90 degrees, and also angle BCD is a right angle, it equals to 90 degrees. Side CB of the shape equals to 8 units. Side DC of this shape equals to 6 units. And side AD of this shape equals to 4 units. And we want to find out the area of this circle. First of all, I will explain you what is one-sided angles. Actually, if we have two lines A and B, and we have the third line C that intersects those two lines at points M and N. Line C intersects with line B at point M, and line C intersects with line A at point N. Angles alpha and beta are defined one-sided internal angles. So alpha and beta are one-sided. Internal angles, while if we have two lines A and B, this is line A and this is line B, and we have a third line C that intersects those two lines at point M and N. So line C intersects with line B at point M, and line C intersects with line A at point N. Then actually here alpha and beta are two one-sided external angles. Okay, here alpha and beta are one-sided external angles. Okay, that is the definition of one-sided angles. Okay, so those two angles alpha and beta are one-sided external angles, while those two angles alpha and beta are one-sided internal angles. Okay, so those alpha and beta are one-sided internal angles, and those angles alpha and beta are one-sided external angles. Okay, and we have a rule. I'll call it rule number 1. Actually, rule number 1 states that one, if the sum of the rats of the two one-sided angles equals to 180 degrees, then the lines are parallel to each other, that is to say, A is parallel to B. Okay, we'll read again rule number 1. Rule number 1 states that if the sum of the one-sided angles, if the sum of the two one-sided angles is equal to 180 degrees, then A is parallel to B. So actually here, if alpha plus beta equals to 180 degrees, okay, if alpha plus beta equals to 180 degrees, then line A is parallel to line B. Okay, again, if alpha plus beta equals to 180 degrees, then line A is parallel to line B. Okay, so if the sum of the one-sided angles is equal to 180 degrees, then the lines are parallel. That is to say, line A is parallel to line B. Okay, and also here the same rule. If alpha plus beta equals to 180 degrees, then line A is parallel to line B. Okay? If alpha plus beta equals to 180 degrees, then line A is parallel to line B. That is according to our first rule. Okay? So we actually can implement rule number 1 in our circle, because actually angle ADC equals to 90 degrees. Angle ADC equals to 90 degrees. And angle BCD equals to also 90 degrees. Okay? Both angles ADC and BCD are equal to 90 degrees. And they are actually one-sided angles. So actually angle ADC plus angle BCD equals to 180 degrees. Okay, angle ADC plus angle BCD equals to 180 degrees, because actually it is 90 degrees plus 90 degrees. And 90 plus 90 equals to 180 degrees. So according to rule number 1, to rule 1, because of the fact that the sum of those two angles is 180 degrees, then AD is parallel to BC. Line A, segment AD is parallel to line segment BC. Okay, again, because of the fact that the sum of those two one-sided angles ACD and BCD equals to 180 degrees, then according to rule number 1, line segment AD is parallel to line segment BC. Okay, so AD is parallel to BC. In the next step, we will connect together points A and C by a straight line, and we will also connect together by a straight line points B and D. And we will call to the intersection point between line segment AC and BD O. Okay, the intersection between line segment AC and BD is defined as O, or point O. And in the next step, we will relate to two triangles, triangle AOD, the green triangle AOD, and the other green triangle BOC. Okay, I write it down. We will focus on triangle AOD. And triangle BOC. Okay, so in those two triangles, angle AOD is equal to angle COB. I'll write it down. Angle AOD equals to angle COB. Okay, in triangles OAD and BOC, angle AOD is equal to angle COB, according to the rule that vertex angles are equal to each other. Vertex angles are equal to each other. Okay, angle AOD equals to angle COB, according to the rule that vertex angles are equal to each other. Actually, I will explain the meaning of vertex angles. When two lines are intersecting each other, so actually we have two lines, line A and line B, that are intersecting each other at point this point. They actually create four angles. The intersection between two lines create four angles. I'll call it by numbers. This angle will be angle 1, this angle will be angle 2, this angle will be angle 3, and this angle will be angle 4. Okay, when two lines are intersecting each other, for example line A intersects line B, they create four angles. Angle 1, angle 2, angle 3, and angle 4. Actually, angle 1 and angle 3 are vertex angles and they are equal to each other. Angle 1 and angle 3 defined as vertex angles. And they are equal to each other. Angle 1 equals to angle 3. And also angle 2 and angle 4 are vertex angles. Okay, angle 2 and angle 4 defined as vertex angles and they are equal to each other. Okay, angle 2 and angle 4 are vertex angles and they are equal to each other, that is to say angle 2 equals to angle 4. So in this drawing, angle 1 and angle 3 are vertex angles and they are equal to each other, and also angle 2 and angle 4 are vertex angles and they are equal to each other, that is to say angle 2 equals to angle 4. Okay, so if we have two lines that are intersecting each other, if we have two lines A and B that are intersecting each other at this point, then angle alpha and beta are vertex angle and they are equal to each other. Okay, alpha equals to beta. So actually angle alpha and beta are vertex angles and they are equal to each other. Or the other possibility is that we have two lines that intersect each other So if those two lines A and B intersect each other at this point, then angle alpha and beta are also vertex angles and they are equal to each other. Okay? Alpha equals to beta. Okay? Here also those two vertex angles alpha and beta are equal to each other, that is to say alpha equals to beta. Okay? So actually you can implement this rule in our circle, because in our circle angle AOD and angle BOC, this angle and this angle, are two vertex angles, and according to rule number 2 states that vertex angles are equal to each other. So I will read rule number 2 again. Rule number 2 states that vertex angles are equal to each other, and actually angle AOD and angle BOC are vertex angles, and therefore they are equal to each other. That is to say, angle AOD equals to angle BOC. Okay, so in those two green triangles, we have the first angle in this triangle equals to the first angle in this triangle. Okay. Okay, angle AOD equals to angle COB. Okay, angle AOD equals to angle BOC. Because of the fact that according to rule number 2, vertex angles are equal to each other, and those two angles, this angle and this angle, are vertex angles. Okay, angle AOD equals to angle BOC, because both those two angles are vertex angles, and therefore, according to rule number 2, vertex angles are equal to each other, and we have already proved that AD is parallel to BC, and actually angle CAO equals to angle BCO. Because actually those two angles are alternating angles, and we have rule number 3 that states that alternating angles between parallel lines are equal to each other. Because of the fact that AD is parallel to BC, actually those two angles are alternating angles between parallel lines, and therefore they are equal to each other. Okay? Alternating angles. Again, angle CAO equals to angle BCO. According to the rule number 3, I will write it here now, that alternating angles, those two angles are alternating angles, and alternating angles between parallel lines, AC is parallel to BC, so alternating angles between parallel lines are equal to each other. Okay? So, actually, I will write down rule number 3. Before that, I will explain in detail what is the meaning of alternating angles. Okay, if we have two lines A and B that are parallel to each other, suppose that is line A and that is line B. So we know that line A is parallel to line B. Then we have a third line C that intersects those two lines A and B. So that is line C in the red color that intersects those two lines at points M and N. Actually, here angle alpha and angle beta are defined as alternating internal angles. Okay, I write it here. Alpha and beta are alternating internal angles. So we can write that if A is parallel to B, if line A is parallel to line B, then alpha equals to beta because of the fact that those two angles are alternating internal angles, and alternating internal angles are equal to each other between parallel lines. Line A is parallel to line B, so the alternating angles are equal to each other if line A is parallel to line B. Okay, that is one possibility, and we have also the theorem of exterior alternating angles. They are also equal to each other if line A is parallel to line B. So if we have two lines, line A and line B, that are parallel to each other, A is parallel to B, and we have another line, line C, that intersects those two lines at points M and N. Then those angles alpha and beta are defined as exterior alternating angles. Okay, I write it down. Exterior alternating angles. Okay, so those alpha and beta are exterior alternating angles, and those alpha and beta are internal alternating angles or interior alternating angles. And here, if line A is parallel to line B, then alpha equals to beta, and also here you have exactly the same rule. If line A is parallel to line B, then alpha equals to beta. Okay, that is actually according to rule number 3, that states alternating angles, no matter if they are exterior alternating angles or interior alternating angles, are equal to each other. Okay, so I write down rule number 3. So rule number 3 states that alternating angles no matter if they are interior or exterior, alternating angles between parallel lines are equal to each other. So I'll read rule number 3 again. Rule number 3 states that alternating angles between parallel lines are equal to each other. So actually, if we know that line A is parallel to line B, then alpha equals to beta. Okay? And also here, if we know that line A is parallel to line B, then alpha equals to beta. Okay? So we actually implemented rule number 3 in our circle because we know that AD is parallel to BC. We proved it in the beginning of the lecture. AD is parallel to BC. So according to rule number 3 that states that alternating angles between parallel lines are equal to each other. So angle DAO equals to angle BCO. Okay, angle DAO equals to angle BCO. Okay. Again, angle DAO equals to angle BCO. Angle DAO equals to angle BCO because of the fact that line segment AD is parallel to line segment BC. So those two angles are alternating angles, and alternating angles are equal to each other. Alternating angles between parallel lines. AD is parallel to BC, and we have two alternating angles, so they are equal to each other according to rule number 3. Okay, and we also can say that angle CBO, this angle equals to angle ADO. So this angle, according to the same rule that states that alternating angles between parallel lines are equal to each other. Those two angles are alternating angles between parallel lines. BC is parallel to AD, so according to rule number 3, they are equal to each other. So we can say, according to the same rule, rule number 3, that angle CBO is equal to angle ADO. For the same reason that those two angles are alternating angles between parallel lines. AD is parallel to BC. Okay. Okay, so angle CBO equals to angle ADO according to the rule that alternating angles between parallel lines are equal to each other. Okay, so we actually proved that three angles of this green triangle equals to equal to three angles are equal to three angles of this green triangle. Okay, so we actually proved that all the angles in this green triangle are equal to all the angles in this green triangle, because actually we proved that this angle is equals to this angle equals to this angle, and this angle equals to this angle. So all three angles in this triangle are equal to the angles in this triangle. So according to the rule of angle, angle and angle, so according to rule A is abbreviation for angle. We prove that three angles in this green triangle equals to three angles in this green triangle. So we can say that triangle BOC is similar to triangle AOD. Okay, triangle BCO is similar to triangle AOD. So according to angle rule, triangle BCO is similar to triangle ADO. Okay, and actually, if we have two similar triangles, we have the following relationship between them. So actually, if the big triangle ABC is similar to the small triangle DEF, that is to say all the angles in this triangle are equal to all the angles in this triangle, then we have the following relationship between the sides of those two triangles. We have the relationship that states that AB over DE equals to BC over EF that equals to AC over DF. Okay, so when we know that two triangles are similar to each other, then we have the following relationship between the sides of those two triangles. AB over DE equals to BC over EF, and it equals also to AC over DF. Okay, so that is the rule of similar triangles. Okay, we have already proved that those two green triangles are similar to each other. Therefore, we can implement the rule of the similar triangles in those two green triangles. We can say that BO over OD equals to BC over AD, or first of all equals to CO over AO, and it equals also DB to BC over AD. Okay, so because of the fact that those two green triangles are similar to each other, we have the following relationship between the sides of those two green triangles. BO over DO equals to CO over AO, that equals to BC over AD. But we know that BC equals to 8 units. So we can write here BC equals to 8 units and AD equals to 4 units. 8 over 4 is 2. So here we can say that BO equals to 2 times OD. Okay, BO equals to 2 times OD. So actually, if we define DO as A, then BO equals 2 times OD, equals to 2 times A, and we also from this equality can say that CO over AO equals to 2. So CO equals to 2 times AO. CO equals 2 times AO. So if AO is B, AO equals to B, then CO equals 2 times AO. CO equals 2 times AO. 2 times AO is 2 times B. Okay. So I will copy again this drawing in the here. Here we have B and 2B. Here we have A and 2A. Okay. Now we'll focus on, we know that angle BCD equals to 90 degrees. Angle BCD equals to 90 degrees. Therefore, triangle BCD is a right triangle. And we can implement the Pythagorean theorem in this right triangle. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so that is to say, BD square equals to BC square plus DC square. Okay, according to the Pythagorean theorem, in the right triangle BCD, the square of the hypotenuse, that is BD square, equals to the sum of the squares of the perpendiculars, equals to BC square plus DC square. Okay, but we know that BC equals to 8 units, so BD square is 8 square. 8 square is 64, equals to first of all, BD equals to A plus 2A, that is 3A. Okay, so BD square is 3A square, equals to BC square is 8 square, that is 64, plus DC square, DC equals to 6, so 6 square is 36. Okay, we got that 3 times A square equals to 64 plus 36, 64 plus 36 is 100, so I write it down. So we got that 3A square equals to 100. Now we will take a root out of this equation. The root of 100 is 10, so we will get that 3A equals to 10. Okay, we took a root out of this equation. The root of 100 is 10, so we got that 3A equals to 10. We will divide this equality by 3. We get that A equals to 10 over 3. So if A equals to 10 over 3, then 2 times A will be equal to 20 over 3. Okay. So I write here that A equals to 10 over 3, while 2 times A equals to 20 over 3. Okay, in the next step we will focus on triangle ADC. We know that angle ADC equals to 90 degrees. Therefore, triangle ADC is a right triangle. And again, we can implement the Pythagorean theorem in this right triangle. So in triangle ADC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC squared is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to AD squared plus DC squared. Okay, that is the implementation of the Pythagorean theorem in this right triangle ADC. But AC is B plus 2B is 3B. So AC squared is 3B squared equals to AD squared is 4 squared is 16 plus DC squared is 6 squared is 36. So we got that 3B squared equals to 16 plus 36. Okay, 16 plus 36 is 52, so I write it down. Okay, we got that 3B squared equals to 52. Okay, now we'll take a root out of this equation. We get that 3B equals to the root of 52. So we took a root out of this equation. We got that 3B equals to the root of 52, but 52 equals to 13 times 4. So I write it down. Okay, 52 equals to 3 times 13. The root of 4 is 2, so I write it down. So we got that 3B equals to 2 times root 13. Now I will divide this equation by 3. So we divided this equation by 3. We got that B equals to 2 over 3 times root 13. So if B equals to 2 over 3 times root 13, then 2 times B will be equal 4 over 3 times root 13. Okay, so we actually can write here that b equals to 2 over 3 times root 13, while 2 times b equals to 4 over 3 times root 13. Okay, so now I will copy this drawing again to here with the numbers without the variables a and b, because we don't have enough place for all the variables and numbers, so I will put only the numbers on the line segments. AO equals to 2 over 3 times root 13. While OC equals to 4 over 3 times root 13. OD equals to 10 over 3, while OB equals to 20 over 3. Okay, so we have actually the values of all the line segments in this circle. Okay, we calculated all the values of the line segments in this circle. So actually in the next step we will extend line segment AC to until point until it touches the circle at point P. Okay, again we extended line segment AC until it touches the circle at point P. Okay, so we created this line segment CP, and now we will calculate the value of CP according to the fourth rule. We have a fourth rule the fourth rule states that if we have two chords, two strings that are intersecting each other, let's say this chord is AB, chord or string, it is the same, and we have the second chord that will be called CD, chord CD or string CD. So those two chords are intersecting each other at this point, let's call this point the intersection point, point O. So we have two chords, chord AB intersects with chord DC at point O. According to the fourth rule, AO times BO, AO times BO equals to CO times DO. Okay, again, if we have two chords that are intersecting each other at point O, then the following equation is true, that AO times BO equals to CO times DO. Okay, so I will write down the fourth rule. Rule number 4 states that if two chords are intersecting each other, chords or string, it is the same. If two chords are intersecting each other at point O, if two chords, that is to say A, B and C, D, okay, if two chords A, B and C, D are intersecting each other at point O, then the following equality is true. AO times BO equals to CO times DO. So I will read rule number 4 again. Rule number 4 states that if two chords A, B and C, D are intersecting each other at point O, then the following equality is true. AO times BO equals to CO times DO. So again we have two chords or two strings, chord AB and chord CD, and they are intersecting each other at point O. Point O is the point of intersection between chord AB and chord CD. then the following equality is true, that AO times BO equals to CO times DO. AO times BO equals to CO times DO. Okay? That is the fourth rule that states that if two chords or two strings, let's say A, B and C, D, are intersecting each other at point O, then the following quality is true: AO times BO equals to CO times DO. Okay, so we actually can implement this rule in our circle. Because we have chord AP that intersects with chord B, D or DB at point O. Point O is the point of intersection between chord AP and chord BD. So we can implement rule number 4 in this drawing. So according to rule number 4, AO times PO equals to DO times BO. Again, chord AP or chord or string AP intersects with chord DB at point O. So O is the point of intersection. So according to rule number 4, AO times PO equals to DO times BO. Okay? Again, according to rule number 4, AO times PO equals to DO times BO. Okay? AO equals to 10 over 3 while BO here AO, it is AO times PO, so okay, so okay, AO equals to 2 over 3 times root 13. Okay, AO equals to 2 over 3 times root 13. Again, AO equals to 2 over 3 times root 13 times PO. PO equals to 4 over 3 times root 13 plus CP we can say that PO equals to OC plus CP, but I shortened it. I immediately wrote that OC equals to 3 over 3, 4 over 3 times root 13 plus CP. So AO times PO equals to DO times BO. DO equals to 10 over 3, while BO equals to 20 over 3. So in total we got that 2 over 3 times root 13 times 4 over 3 times root 13 plus CP equals to 10 over 3 times 20 over 3. Actually, we have 3 in this side of the equation, in the denominator, and we have 3 in this side of the equation, in the denominator of this side of the equation. So 3 can be cancelled. So what left here is 2 times over root 13 times 4 over 3 root 13. So we have here root 13 times root 13 is 13. In total we have here 8 over 3 times 13. Okay, 2 times 4 is 8, and here we have 3, so, and root 13 times root 13 is 13, plus 2 times root 13 times CP equals to 10 times 20 is 200 over 3. Okay. So here 3 times 13 is 104. So I write it down. Okay, 8 times 13 is 104, so in total we got that this expression is 104 over 3 plus 2 times root 13 times CP equals to 200 over 3. Now we subtract 104 over 3, we move it in the other side of the equation. I shortened of the actions, so actually I moved this expression to the other side of the equation, and 200 minus 104 equals to 26. So in total we have here 26 over 3, and here we have 2 times root 13 times CP. Okay, so actually 26 over 3 is 32, so I write it down. So we got that 2 times root 13 times CP equals to 32. We divide this equation by 2. Okay, we divided this equation by 2. We got that root 13 times CP equals to 16. We will divide this equality by root 13. We will get that CP equals to 16 over root 13. Okay, we found out the value of CP. We found that CP equals to 16 over root 13. So I will write here that CP equals to 16 over root 13. Okay. In the next step, we will extend line segment DC until it touches the circle at point Q. Again, we will extend line segment DC until it touches the circle at point Q. The touching point between the chord and the circle is point Q, and we will calculate the value of line segment CQ that we created by the same rule, by rule number 4, that states that if two chords are intersecting at point C, then actually we have chord DQ that intersects with chord AP at point C. That is to say, according to rule number 4, DC times CQ equals to AC times CP. Okay, so we implemented rule number 4 here in order to find out the value of CQ. According to rule number 4, if we have two chords that are intersecting each other, here we have chord DQ that intersects with chord AP at point C. So at the point of intersection we have the following relationship, that DC times CQ equals to AC times CP. So I write it down. According to rule number 4, DC times CQ equals to AC times CP. So actually chord DQ intersects with chord CP at point C. Yes, at point C. Okay, chord DQ intersects with chord CP at point C. So according to rule number 4, TC times CQ equals to AC times CP. Okay, we implemented rule number 4 on those two chords, CP and DQ that are intersecting at point C. So according to rule number 4, DC times CQ equals to AC times CP. Okay, but we know that DC equals to 6 units. CQ is the variable that we want to find out, so I write it as it is, equals to AC. AC is actually 2 over 3 times root 13 plus 4 over 3 times root 13. Okay, and CP, we have already found out that the value of CP is 16 over 13 over root 13 units. Okay, CP equals to 16 over root 13 units. Okay, so in total we got that DC times CQ equals to AC times CP, so that is to say 6 times DQ equals to this expression. Okay, so now we'll do the arithmetic of this expression. Two over 3 times root 13 plus 4 over 3 times root 13 equals to 6 over 3 times root 13. So I write it down. Okay. Again, 2 over 3 times root 13 plus 4 over 3 times root 13 equals to 6 over 3 times root 13. We multiplied it by 16 over root 13. 6 over 3 is 2, so I write it down. Actually, we have 6 over 3 is 2, but we have also root 13 in the numerator, and we have root 13 in the denominator, so it cancelled, and we left only with 2 times 16, that is 32. Okay, 2 times 16 is 32. Now we will divide this equation by 6. We will get that CQ equals to 32 over 6 units. Or CQ equals to 16 over 3 units, yes? So we divided 32 by 6. 32 over 6 is 16 over 3. So we found out that the value of the new line segment that we created, CQ, equals to 16 over 3 units. Okay, so here we know that CQ equals to 16 over 3. Okay, in the next step, we will extend line segment BC until it touches the circle at point R. And as we did before, we created a new line segment RC. We will find out the value of RC according to the fourth rule. Okay? We have chord RB. Chord RB intersects with chord DQ. So according to rule, so I write it down, chord RB chord RB intersects with chord DQ at point C. Whenever we have two chords that are intersecting each other, we can implement rule number 4. Okay? So, according to rule number 4, okay, again, chord RB or string RB intersects with chord DQ at point C. So according to the fourth rule, RC times CQ, RC times CB equals to DC times CQ. Again, we have chord DQ that intersects with chord RB at point C, so we can implement rule number 4 that states that if two chords are intersecting each other, so at the point of intersection, we have this rule that RC times CB equals to DC times CQ. RC is the variable that we want to find out. Okay, RC remain as it is. Will remain as it is. CB equals to 8.8 units. DC equals to 6 units. And CQ equals to 16 over 3. Okay, in total we got that RC, it is the variable that we want to find out, so it remains as it is. CB equals to 8 units, DC equals to 6 units, and CQ equals to 16 over 3. Okay? Here, 6 over 3 equals to 2, so I write it down. 6 over 3 equals to 2. Okay, here 6 over 3 equals to 2. Here we have 16. I left it as it is. So it is RC times 8 equals to 2 times 16. 2 times 16 is 32. So I write it down. So we got that RC times 8 equals to 32. We divide this equality by 8. (32 over 8 is 4). So we got that RC equals to 4 units. Okay? So actually we calculated all the line segments, the values of all the line segments in this circle. The only thing that is left to find out is the radius of this circle, and we will implement rule number 5 in order to find out the radius of this circle, and then we know that the area of this circle equals to pi times the radius squared, and we'll multiply the radius, or we will multiply pi by the radius squared, and we will find out the area of this circle. So rule number 5 states that if two chords intersects at 90 degrees, if two chords intersects at 90 degrees, then the following equality is true. So actually I will show you the rule number 5. If we have two chords that are intersecting each other at 90 degrees, suppose that we have here chord AB that intersects with chord CD, at point O, and creates 90 degrees. At the point of the intersection, we have 90 degrees between those two chords. Okay? So actually, rule number 5 states that 4 times r squared, when r is the radius of this circle, equals to AO. O is the point of intersection, so it is AO square plus BO square plus DO square, or plus CO square, plus DO square. I will read rule number 5 again. If two chords intersect with each other at 90 units, at 90 degrees, then the following equality is true. A 4 times r square equals to AO square plus BO square plus CO square plus DO square, when O is the point of intersection between those two chords. Okay? 4 times r square equals to AO square plus BO square plus CO square plus DO square. Okay? We actually can implement rule number 5 in our circle in order to find out the value of the radius of this circle, and then we'll use the formula for the radius for the area of a circle, that is the area of a circle equals to pi times the radius squared, and we'll find out the area of this circle. As you can see in the drawing, we have chord DQ that intersects with chord RB at 90 degrees. I will write it down. Chord DQ intersects with chord RB at 90 degrees. This is a right angle, so it intersects the two chords are intersecting at 90 degrees. Therefore, according to rule number 5, according to rule number 5, C is the point of intersection between chord DQ to chord RB, and at the intersection point we have 90 degrees. So we can implement rule number 5 in this circle. So according to rule number 5, 4R squared equals to DC squared plus CQ squared plus BC squared plus RC squared. Okay, so I'll read it again. Chord DQ intersects with chord RB at 90 degrees, and actually at the point of intersection, that is to say point C, the two chords creating 90 degrees with each other. C is the point of intersection, and the two chords RB and DQ creating 90 degrees with each other. So we can implement rule number 5 that states that if two chords intersect with each other at 90 degrees, then the following equality is true, that 4 times R squared equals to DC squared plus CQ squared plus BC squared plus RC squared, when C is the point of intersection, and at that point the two chords creating 90 degrees with each other. For that reason we can implement rule number 5. Okay, so actually 4R squared equals to DC is 6, so DC squared is 36 plus CQ equals to 16 over 3 is 5.333, so it is actually 5 thirds square plus BC is 8, so BC square is 64 plus RC is 4, so RC square is 16. So in total we got that 4R square equals to 36 plus 5.33 square plus 64 plus 16. 36 plus 64 is 100, 100 plus 16 is 116. So in total we will get that 116 plus total we got that 4R squared equals to 116 plus 28.44, 116 plus 28.44 equals to 144.44. Okay, we got that 4r squared equals to 144.44. We'll divide this equality by 4. So actually 144.444 divided by 4 is 63 0.111. So we got that r square equals to 36.11. The area of a circle equals to pi times r squared. Okay, the formula for the area of a circle is pi times r squared, and we know that r squared equals to 36.111, so the area of the circle equals to pi times 36.111 square units. So the area of the circle equals to pi times 36.111 square units, or in terms of numbers is the area of the circle equals to 113.45 square units. Okay, so the area of the circle equals to 113.45 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this circle, and we have two angles that are right angles, and we have here two right angle BCD equals to 90 degrees, and angle ADC also equals to 90 degrees. We know that line segment CB equals to 8 units, line segment DC equals to 6 units, and line segment AD equals to 4 units. And So we want to find out the area of this circle, and we have here two angles that equals to 90 degrees, and the sum of these two angles equals to 180 degrees. And we have rule number one, that if we have in the first of all I will explain what is one-sided angle. If we have two lines, line A and line B, and the third line C that intersects those two lines at point M and N, so it creates two angles, angle alpha plus angle alpha and angle beta, and those angles alpha and beta are considered as one internal one-sided angles, and while those two angles alpha and beta are considered as external one-sided angles. And rule number one states that if alpha plus beta equals to 180 degrees, if the sum of those two angles equals to 180 degrees, then line A is parallel to line B. Okay, also here, if the sum of angles alpha and beta equals to 180 degrees, then line A is parallel to line B. Okay, so I'll read rule number one. It states that if the sum of two one-sided angles equals to 180 degrees, then the lines are parallel to each other. That is to say, A is parallel to B. Okay, so actually we can implement rule number one in our circle, because we have here two internal angles that the sum of those two internal angles equals to 180 degrees. So according to rule number one, we have two one-sided angles, two internal one-sided angles, that the sum of them is 180 degrees. So according to rule number one, AD is parallel to BC. Okay? According to rule number one, because of the fact that the sum of those two inside right angles, internal right angles, equals to 180 degrees, AD is parallel to BC. Okay? And then we connected together points B and D by a straight line, and we connected together points A and C by a straight line. The intersection between those two line segments, BD and AC, is at point O. And then we actually focused on the green triangle AOD and the opposite green triangle BOC, and these two green triangles angle AOD equals to angle BOC, because according to the rule number 2, that states that vertex angles, those are vertex angles are equal to each other. Again, what is vertex angles? When two lines are intersecting each other at this point, they create four angles. Angle 1 and 3 are vertex angles, therefore they are equal to each other, and also angle 2 and 4 are vertex angles, and therefore they are equal to each other. Okay, so actually an example of two vertex angles, angle alpha and angle beta are vertex angles, so according to rule number 2 they are equal to each other. And also here, angle alpha and beta are vertex angles, therefore according to rule number 2 they are equal to each other. Again, rule number 2 states that vertex angles are equal to each other. So we actually implemented rule number 2 in our circles, because angle COB and angle AOD are vertex angles, and according to rule number 2, vertex angles are equal to each other, therefore angle AOB equals to angle BOC. Okay, and again we have the term alternating angles. If we have two lines, line A and line B, and the third line, line C, intersects those two lines at points N and M, then those two angles, angle alpha and angle beta, are defined as internal alternating angles. Actually, if we know that line segment, line A, is parallel to line B, then alpha equals to beta. Alpha and beta are alternating angles, and alternating angles are equal to each other in parallel lines. In parallel lines, alternating angles are equal to each other. Alpha and beta are two alternating angles, internal alternating angles, and they are equal to each other if A is parallel to B. So here we have two interior alternating angles, and if we know that line A is parallel to line B, then alpha equals to beta. Those are internal or interior alternating angles, and if A is parallel to B, then alpha equals to beta. And also those two angles are exterior alternating angles. If we know that that line A is parallel to line B, then angle alpha equals to angle beta, because alternating angles between parallel lines are equal to each other. So if A is parallel to B, then alpha and beta, that are exterior alternating angles, are equal to each other. So actually rule number 3 states that alternating angles between parallel lines are equal to each other. So if we know that A is parallel to B, then alpha equals to beta. Those are two exterior alternating angles, and if we know that A is parallel to B, then alpha equals to beta. And also here, if we know that line A is parallel to line B, then alpha equals to beta. Those two angles are interior alternating angles, and interior alternating angles between parallel lines are equal to each other. So actually, therefore, according to rule number 3, angle DAO equals to angle BCO. This angle equals to this angle because of the fact that AD is parallel to BC. So those two angles are alternating angles, and alternating angles between parallel lines are equal to each other. So AD is parallel to BC, and we have two alternating angles, and alternating angles are equal to each other between parallel lines. AD is parallel to BC, so those two alternating angles are equal to each other. Okay, and for the same reason, also angle CBO equals to angle ADO. This angle equals to this angle equals to this angle, because of the fact that we have two lines that are parallel to each other. AD is parallel to BC, and those two angles are alternating angles between parallel lines. Therefore, according to rule number 3, they are equal to each other. So this angle equals to this angle. For the same reason, this angle also equals to this angle. So we actually proved that according to angle, this green triangle BCO equals to the small green triangle AOD, because we proved that 3 angles in this triangle equals to 3 angles in this triangle. This angle equals to this angle, this angle equals to this angle, and this angle equals to this angle. So 3 angles from this green triangle equals to 3 angles from this small green triangle. Therefore, those two triangles are similar to each other. Okay, the big green triangle are similar to the small green triangle. Okay, and we have a rule in if we have two triangles that are similar to each other, the big triangle ABC is similar to the small triangle DEF. That is to say, 3 angles from this triangle are equal to 3 angles to this triangle. Then the following relationship is true, that AB over DE equals to BC over EF, and it equals also to AC over DF. Okay, so we have already proved that those two green triangles are similar to each other. Therefore, the previous relationship is true between them. Therefore, BO over DO equals to CO over AO. Okay, BO over DO equals to CO over DO equals to BC over AD. over AD. Okay, BO over OD equals to CO over AO equals to BC over AD. But we know that BC equals to 8 units and AD equals to 4 units. Okay, BC equals to 8 units and AD equals to 4 units. So 8 over 4 is 2. So we actually have the equation that BO over OD equals to 2. So 2 times OD, if we multiply this equality by OD, we will get that 2 times OD equals to BO. And also we have the equality that CO over AO equals to 2. So CO, if we multiply this equality by AO, we'll get that 2 times AO equals to CO. Okay? So actually here if AO equals to B, then CO equals to 2B, because CO equals 2 times AO. CO equals 2 times AO. So if AO is B, then CO is 2 times AO, that is to say is 2 times B. And again, in the same equality we have about BO equals 2 times OD. So if BO, if OD equals to A, then BO equals 2 times OD, BO equals to 2 times A. Okay? So we have the values of this line segment in terms of A and B, and in order to find out the values of A and B, we implemented the Pythagorean theorem on these two right triangles. Actually, we have angle BCO that equals to 90 degrees. Therefore, triangle BCO is a right triangle. We can implement the Pythagorean theorem on the right triangle BCO. According to the Pythagorean theorem, BD square equals to BC square plus DC square. BD square equals to DC square plus BC square. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? And we know that DB equals to 2A plus A is 3A, and DC equals to 6, and BC equals to 8. Okay? So we have only one variable, that is A, because DB equals to 3A, DC equals to 6, and BC equals to 8. So we can easily find out the value of A. We found out that A equals to 10 over 3, and 2 times A equals to 20 over 3. Okay? And then we know that angle ADC equals to 90 degrees. So triangle ADC is a right triangle. So again we can implement the Pythagorean theorem that states in this right triangle ADC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AD square plus DC square. Because this is a right triangle. This angle is 90 degrees. This is a right triangle. We implemented the Pythagorean theorem on this right triangle. And we actually know that AC equals to A plus AC equals to A plus 2A equals to 3A. here AC equals to B plus 2B equals to 3B, AC equals to 3B, DC equals to 6, and AD equals to 4. So we have 4B square equals to 6 square plus 4 square. Okay, the only variable that is that we have here is B, and we found out that the value of B is 2 over 3 times root 13, and 2 times B equals to 4 over 3 times root 13. Okay, so actually in this way we found out the values of all the line segments that we have here. We actually found out that the value of A is 10 over 3, 2A is 20 over 3, B is 2 over 3 times root 13, and 2 times B is 4 over 3 times root 13. Okay, so we actually know the values of all the variables, all the line segments in this circle. Okay, so in the next step we have rule number 4 that states that if two chords A, B, and C, D are intersecting each other at point O, then the following equality is true. AO times BO equals to CO times DO. So actually we have two chords, chord AB and chord CD, that are intersecting at point O. According to rule number 4, AO times BO equals to CO times DO. Okay, and we actually implemented rule number 4 in our circle. First of all, we extended line segment AC until it touches the circle at point P, and then we calculated the value of CP according to rule number 4, because we actually have line chord AP that intersects with chord DB at point O. So according to rule number 4, AO times PO, the point of intersection between AP and BD is at point O. So according to rule number 4, AO times PO equals to BO times DO. Okay? According to rule number 4, AO times PO equals to DO times BO, because we have chord AP that intersects with chord DB at point O. So we implemented rule number 4 in order to find out the value of CP. We have all the values of these line segments, so the only variable that is missing is CP, and we actually found out that CP equals to 16 over root 13, okay? CP equals to 16 over root 13. Okay, then we extended line segment DC until it touches the circle at point Q, and in order to find out the value of CQ, we implemented again rule number 4. We have chord DC that intersects with chord DQ intersects with chord AP at point C. Okay, so actually DC times CQ equals to AC times CP. Again, chord DQ intersects with chord AP at point C, so according to rule number 4, DC times CQ equals to AC times CP. Okay, so we actually have all DC times CQ equals to AC times CP, and we have all the values of the line segments here. The only variable that is missing that is CQ, and we found out that CQ equals to 16 over 3 according to this equation. The only variable that is missing that is CQ. We put all the data in this equation and we found out that CQ equals to 16 over 3. Okay, and then we extended chord BC until it touches the circle at point R, and we implemented rule number 4 in order to find out the value of RC. Actually, chord RB intersects with chord DQ at point C. Again, chord RB intersects with chord DQ at point C. Therefore, we can implement rule number 4 that states that RC times CB equals to DC times CQ. Again, chord DQ intersects with chord RB at point C. Therefore, according to rule number 4, RC times CB equals to DC times CQ. Again, RC times CB equals to DC times CQ. Again, we have all the values of the variables here except of the RC, and we found out that RC equals to 4 units. RC equals to 4 units, and then in order to find out the radius of this circle, we actually implemented rule number 5 that states that if two chords intersects with each other at 90 degrees, then the following equality is true. We have two chords. Chord AB intersects with chord DC at point O at 90 degrees. Therefore, according to rule number 5, 4R squared equals to AO squared plus BO squared plus CO squared plus DO squared. Again, chord AB intersects with chord DC at point O at 90 degrees. Therefore, according to rule number 5, CO square plus DO square plus AO square plus OB square equals to 4 times R square. R is the radius of this circle, or 4 times R square equals to OC square plus OD square plus AO square plus BO square. Okay, and again we can implement this rule in our circle, because actually we have chord DQ intersects with chord RB at point C at 90 degrees. Again, chord DQ intersects with chord RB at point C at 90 degrees. This angle is 90 degrees. So according to rule number 5, DC square plus CQ square plus RC square plus BC square equals to 4 times the radius squared. Okay, 4 times the radius square equals to DC square plus CQ square plus RC square plus BC square plus RC square. Okay, and we actually know the values of all these variables. We know all the values. So the only thing that is missing is the radius. So we know that DC equals to 6 units. CQ equals to 16 over 3. And BC equals to 8 units, and RC equals to 4 units. The only thing that is missing is the radius. Okay, so we put all the data that we have all the values of all the line segments here, and the only missing variable is the radius of this circle. So the only thing that is left is to put all the data in this equation and to find out the value of R, that is the radius of this circle. We found out that R square equals to 36.111, and the area of any circle equals to pi times the radius squared. Okay, so we found out that the area of this circle equals to pi times 36.111 square units. So the area of this circle equals to 113.45 square units. Okay, thank you very much.